Hello everyone, welcome back to my channel. I'm Vishit Ramesh and in this video, I'm going to be speaking about the Huffman trees. So let's get started. Introduction. Huffman's encoding is one of the most important file compression methods. In addition to its simplicity and versatility, it yields an optimal, that is, minimal length encoding. This technique is known as Huffman coding, which was developed by David A. Huffman in 1952. The process of building a Huffman tree involves analyzing the frequency of each character in the input data and creating a binary tree where each leaf node represents a character and its frequency. Suppose we have to encode a text that comprises symbols from some n-symbol alphabet by assigning to each of the text symbols some sequence of bits called the code word. There are two ways of encoding: fixed length encoding and variable length encoding. Greedy algorithm for Huffman tree. What is greedy algorithm? Greedy algorithm is an algorithmic strategy that makes the best optimal choice at each small stage with the goal of this eventually leading to a globally optimum solution. This means that the algorithm picks the best solution at the moment without regard for consequences. It picks the best immediate output but does not consider the big picture. Hence, it is considered greedy. A greedy technique for Huffman tree. The algorithm builds the Huffman tree in a bottom-up manner using the minimum nodes every time. This is called a greedy approach because each character gets its length of code depending on its frequency in the given stream of data. The Huffman's algorithm. So first we create a priority queue consisting of each unique character. Sort them in ascending order of their frequencies. For all the unique characters, create a new node, extract minimum value from queue and assign it to left child of new node. Extract minimum value from queue and assign it to right child of new node. Calculate the sum of these two minimum values and assign it to the value of new node. Insert this new node into the tree. Return root node. Types of encoding. Fixed length encoding. This method assigns to each symbol a bit string of the same length m. This is exactly what the standard ASCII code does. One way of getting a coding scheme that yields a shorter bit string on the average is based on the old idea of assigning shorter code words to more frequent symbols and longer code words to less frequent symbols. Variable length encoding. This method assigns code words of different lengths to different symbols, introduces a problem that fixed length encoding does not have. To avoid this complication, we can limit ourselves to the so-called prefix-free codes. In a prefix code, no code word is a prefix of a code word of another symbol. Hence, with such an encoding, we can simply scan a bit string until we get the first group of bits that is a code word for some symbol, replace these bits by the symbol, and repeat this operation until the bit string is reached. So the encoding using Huffman algorithm. To calculate the frequency of each character in the string, such as 1, 6, 5, and 3 assigned to B, C, and AD respectively. So first, we sort the characters in increasing order of their frequency, which are stored in a priority queue, such as 1, 3, 5, 6, which responds to B, D, and A, C. So make each unique character as a leaf node. Create an empty node Z, assign the minimum frequency to the left child of Z, and assign the second minimum frequency to the right child of Z. Set the value of the Z as the sum of the above two minimum frequencies, such as B and D are the minimum nodes, so we add them and create a root node 4 and align them according to the ascending order, such as 4, 5, and 6. Then we remove these two minimum frequencies from Q and add the sum into the list of frequencies, as I told. Now insert node Z into the tree. Now we repeat the steps 3 to 5 for all the characters. Now 4 and 5, which are the minimum nodes, are added and the 9 is added into the queue, and then 6 is also added, making it as 50. For each non-leaf node, assign 0 to the left edge and 1 to the right edge. The total size is given by the table below. For character A, which is having frequency 5, the code is 11. Size is 5 into 2, that is 10. For character B, the frequency, which is 1, has a code 100, which has a size 1 into 3, which is 3. For character C, the frequency is 6, having code 0, having size 6 into 1, which is 6. Character D, having frequency 3, has the code 101, which has the size 3 into 3, which is 9. The 4 into 8, 32 bits. Frequency is total is 15 bits, and the total size is 28 bits. Without encoding, the total size of the string was 120 bits. After encoding, the size is reduced to 32 plus 15 plus 28, which is 75 bits. So now decoding the code. For decoding the code, we can take the code and traverse to the tree to find the character. Let us take an example such as 101, which is to be decoded. We can transfer from the root as shown in the figure below. So we start from 15 and 1, we go to 9, and then to 4, and then to 3. So we transverse and reach the ending D. So the conclusion. We have learned that Huffman Tree is a powerful tool for data compression and encoding. Through its efficient algorithm, it can reduce the size of data without losing any information. We have seen how to build a Huffman tree, encode and decode messages using it, and compared it with other compression algorithms. Understanding Huffman tree is important not only for computer science students, but also for anyone who deals with large amounts of data. It can be used in various real-world applications such as image encoding and data compression. By mastering this concept, you can improve the efficiency of your work and save valuable time and resources. Thank you everyone for watching this video. I hope you like and share this video. If you have any doubts, put them down in the comment sections below. Thank you.